Hello everyone, wishing you all a very good morning. I hope I'm audible and visible to all of you. Can you see me? Can you hear me? Everyone in the class? Am I audible and visible to all of you? Can you please raise hands and let me know that I am audible and visible? Hello everyone, can you see me? There's no one in the online class, so I don't know whether I am audible or visible. Am I audible and visible to all? Anyone in the class, can you hear me? Hello? Is the mic off or the speaker off? Can you hear me, everyone? Am I audible and visible to all of you? Can you raise hands and let me know that I'm audible? I don't think I am audible. So let's start today's class. In the last class, we had discussed, what did we discuss? I think we had discussed work done by a variable force. And the last point that we did was to find out work done from the area under the force displacement graph, or for that matter, acceleration displacement graph. Now, if you can recollect what we had done, and I'll just go through, if you have a force displacement graph, instead of calling it as a force displacement graph, I should call it as force position graph. But in the questions that you will get in the exam, probably it will be given in the form of force displacement graph. So on x-axis, the displacement along x-axis would be the displacement or position would be plotted, and on y-axis, the displacement, the force would be plotted. Now, this thing holds good as long as you have a one-dimensional force. So you can very easily find out the work done by a one-dimensional force using the area under the graph. Am I audible to all? Okay, so it is very simple to find out the area under this graph. And I told you area above x-axis will be taken as positive. Area below x-axis would be taken as negative. Now, there is a general question, a normal question that can come. What if, and please listen to the question carefully, what if I have a three-dimensional force? Now, three-dimensional force normally has not come in your JEE Advanced even, but can it come anytime? What if I have a three-dimensional force? Now, this three-dimensional force can be constant, it can be variable. Now, if you are given a three-dimensional force, or probably you are given the force displacement graph for a three-dimensional force, the first question that arises is, how will I make the force displacement graph for a three-dimensional force? I can only plot one force on one axis. I cannot plot three forces on one axis. You can do that, but the diagram will look very complicated and it will become very difficult for you to understand what is happening. The question still remains, if it's a three-dimensional force, how will the graph look like? Question number one. And question number two is, once you have the graph, what will you do with it? Obviously, you'll have to find the area of that graph. When you find the area of the graph, what will you do? So let us encounter each and every question separately. Let us first discuss how that graph of a three-dimensional force would look like. Obviously, I cannot draw three graphs on one. I can draw it, but it looks complicated. So how do I do it? Now, this is how I do it. Now, if you can see here, this is on the x-axis, I have plotted the position along x. Instead of calling it position, the question may say displacement. Position along x. And on y-axis, what I have done, I have plotted fx. Now, you must remember this fx is the force ka x component. So, I have plotted force ka x component on the y-axis, and I have plotted the position on the x-axis, which is position on the x-axis. Now, I will repeat the same steps. I will repeat the same steps for y-axis. So, I will plot y-axis, my position on the x-axis. Please don't confuse y-axis and x-axis. So, a particle is moving in 3 dimensions. It will have some displacement along x, it will have some displacement along y, and it will have some displacement along z. Change in position. So position will be changing. Position will be changing along x-axis. So that is plotted in graph number 1. Position will be changing along y-axis, which is plotted in graph number 2, where I have plotted position on the y-axis, on the horizontal axis. Let me not call it x-axis. For the horizontal axis, I have plotted position along y. And on the vertical axis, I have plotted Fy, which is the force ka y component. Now, if you have understood this, then you should be able to make out what I am going to do with the third component. And with the third component, I will simply plot what? Position along z-axis on the horizontal axis, and force ka z component along the vertical axis. I hope you are understanding what I am getting to, where we are heading towards. So now I have 3 separate graphs. Graph number 1 is a graph between fx and position along x. Graph number 2 between fy and position along y. And graph number 3, fz and z. Now the question becomes very simple. Now let's make a question here, because you will not find this question in books. It has hardly come in any exam. It has never come in any exam. So I'm just going to make a question now. I'll just make a question here like this. For example, if I say, this is the graph of fx along x. Now everything is plotted in SI units. So this force is, let us say, -2 newtons. This is, let us say, 5 newtons. This position is, let us say, 5 units, 5 meter, and this position is, let us say, 8 meters. So this is graph number 1. Let me plot graph number 2. And graph number 2, this is 0, this is 8, and this is, let us say, 3 newtons. This is graph number 2. And let us say this is graph number 3. This is 6. This is 2 Newton. And now I tell you, this is how a force varies, a 3-dimensional force. These are the graph of 3-dimensional force. What is the work done by this force? Let me change this so that it looks different. What is the work done by this force? This force has displaced the particle from 0, 0, 0, which is your origin, to a point 8, 5, 6. Find the work done by this force. Can you find out the work done by this force in displacing the particle from origin to the point 8, 5, 6. And your time starts now. How will you do it? Well, apply some common sense. Let us see who can do this. I'll give you 1 minute, 2 minutes to solve it. Should not take more than 2 minutes. If you have understood the concept, it should not take you 2 minutes, more than 2 minutes. So more than 2 minutes is more than enough to calculate it. If anyone has got the answer, you can raise your hands and use the mic and tell me what is the answer. Anyone got anything that looks like an answer? Again, I always keep on telling you, answer is not important. Answer is the last thing that I'm concerned about. More concerned about how you are attempting this question, whether you are attempting it in the right way. The attempt is important, answers are not. Anyone got any answer? I'll give you 1 more minute. There's no one in the online class today. Okay. I think most of you have come for the offline class then. Okay. It's time for us to solve this question. So how will I solve this question? I have to find the area. So let me first find this green area. How much is this green area? It is very simple. 5 multiplied by 5. So this is 25. And since this is above x-axis, I will take it as plus 25. Okay. What about the next area? Next area is this one. Now, as you can all understand, this is below x-axis. I would be changing my thing, x-axis, below x-axis, and my above x-axis. So how much is this? The length is 3, the breadth is -2 or 2, whatever you call it. So it is -6. Why I'm calling it -6? Because one thing is positive and the other thing is negative. What about this one? So if I have to find out the area of this fx and dx, between fx and x, the area will be 25 minus 6. So I will get the net answer as the work done of this will be the summation of these two, 25 and minus 6. So the answer for this one would be 25 minus 6. I think it is plus 19. So the answer for this one is plus 19. I got the work done as plus 19. I move on to the next one and I just find the area of this one. This is simply triangle, half base into height. Half is half. Base is 3 or base is 5. Height is 3. 15 by 2. So the answer is plus 15 by 2. There is no negative area. So this is the only answer. The first answer is plus 19. The second answer is plus 15 by 2. Now I can move further ahead and find the third area. This is the third area. It has to be positive as well. 2 multiplied by 6 plus 12. That is the third area. I've got the 3 areas. But the question was, not finding out the areas. The question was, what is the work done by this force? And what is the answer for this one? How will I get the work done by this force? What is the work done by this force? Can anyone tell me? What is the work done by this force? No one? Okay, if there is no one, I'll tell you. Plus 19, which is the work done by the x component of force, plus 15 by 2, which is the work done by the y component of the force, plus 12, which is the work done by the z component of the force. We need to add these three and we end up with the answer. This will be the work done by this force. Do we understand this? Can I have some raise hand that we understand this? How many of you were able to do this? Only 2 people, 3, 4, 5. Okay. So this is how it has to be done. If it is given as a 3-dimensional force, hardly you will encounter this question, but if you encounter this, probably you will be the only one who would have done this in the class, in the entire country. So you must be proud of yourself and you can do it in the examination hall also. Now, coming back to one more question that has suddenly came into my mind. So I will not done this question before, just somehow came into my mind now. So I'll just formulate another question. Now this question is not of force in 3 dimension. It is simply about a force in 1 dimension. So I have plotted the position along x and I have plotted the force. You must understand that this force would be along x-axis. We have done enough to understand this. Now this force varies like this. Ting ting. This is -4. This is -2. This is 0. This is +1. This is +3. This is -2 Newton. This one is -3 Newton. Left hand side is -2, right hand side is -3. You will say, sir, both are looking same. Okay. And this one is 1 Newton. Now this force is displacing this particle from the coordinate, as you can see, -4 to +3. This force has displaced this particle from -4 to +3 along x. Force is also along x. Can you find the work done by this force? Your time starts now. Let us see who can understand how to do this. Now, this is the question that can be come because this is a 1-dimensional force. What is the work done by this force? Okay. Has everyone done this? Now, you just need to find the areas, right? How will you find the areas? Okay, let us first write the areas. What is the area of this one? No, beta, I can't hear you. Is there anything that you want to ask? Answer is minus 18. Okay, you got the answer as minus 18. Well done. Well done. Okay. How did you get minus 18? You first find out this area. How much is this? 4 multiplied by 2. It is 8. Will it be positive or will it be negative? That is the next question that is coming to you. Will it be positive or will it be negative? That is what I need to ask you. Positive or negative? And how will you decide that? Whether it is positive or negative? Okay. How many for positive? How many for positive? It is negative or positive? Okay. Let us move on to the second area. Okay. Let me talk about this area. How much is this area? This is 2 multiplied by 1. So this is 2. Positive or negative, we don't know. What about this one? 1 multiplied by 1? 1. Okay. What about this one? 2 multiplied by 3? It is 6. Okay. Everyone, I think, is concerned. Everyone, I understand that this is negative area. Yes or no? This is negative area. Yes or no? Yes, this is negative area. Okay. What about this one? What about this one? Everyone, I think, understand that this is positive area, not a problem. Plus 1. Now, let us move on to the controversial ones. The first controversial one is 2. Positive or negative? How many for positive? How many for negative? Positive first. Raise your hands. That this is positive. I don't have any raise hands. How many for negative then? Raise hands. So many for negative. So I will give this to negative. It is definitely negative. This is minus 2. Force is positive. Displacement is negative. That gives us minus. Now on that same logic, what about 8? Positive? How many for positive? How many for negative? Positive first. No one for positive. How many for negative then? 3 or 4 are for negative. None are for positive. That means rest of them are not convinced. This is a positive area beta. Force is also negative and displacement is negative. So this is positive. Got it? And that was the reason I gave you this question. So basically what you see here is force is the multiplication of force and displacement, right? So F dot. Now, if you multiply 2 positive things, you get a positive. If you multiply 2 negative things, you also get a positive. Should multiply one positive with the other negative? The answer is definitely negative, and that is the reason you have all these plus and minus coming in. So what is the final answer I am getting? -6 minus 2 is -8. -8 and plus 8 get cancelled. My final answer is not this. Final answer is not this. My final answer is +1. Do we understand this? Can I have some raise hand that we understand this? How we have done this? Do we get this? Do we get the final answer? How we have done this? Yes or no? Do we get it? Is there a problem with the sound?
Sir,
Yes, beta.
explain once again, sir.
Positive multiplied by positive is positive. Negative multiplied by negative is positive. Positive multiplied by negative is negative. And that is the reason that we are getting this. The first area here, positive, negative is multiplied by negative, therefore it is positive. In the second region, force is positive, displacement is negative, therefore it is negative. In the third case, both are positive, that's why it's positive. In the fourth case, one is positive, force is negative, and displacement is positive, and hence the answer is -6. Do we get this? Multiplication of two things, both are positive, positive, both are negative, positive, positive, negative, it's always negative. Do you understand this now? Or you still have doubt?
Sir, can you hear me?
Yes, but I can hear you.
Sir, explain once again, sir.
What have you not understand? Please let me know. Positive multiplied by negative. What is positive multiplied by negative? It is negative. Here force is positive, displacement is negative, so negative. Here force is negative, displacement is positive, so it is negative. What have you not understood, beta? Don't understand which one is positive, which one is negative? In this case, force and displacement both are positive, and hence the answer is positive. In this case, force and displacement both are negative, and hence the answer is positive. Do you understand this all? Please
Sir.
raise your hands. Yes.
-4 minus of -2, the body will cover only -2 distance, no sir? Why did you take 4 into -2, sir?
Where? Beta, 4 into -2. I have to find out the oh. Okay, 2 into 2, 8. Sorry, 4. I multiplied wrongly. Right. Now correct? Plus 4. I multiplied wrongly. That is what you are saying? That should be plus 4, right? That is what you are saying?
Yes, sir.
Okay. Yes, that is correct. So what is the final answer then? -6 -2. I think I have not done the same mistake here anywhere else. Okay, I just probably I multiplied -4 with 2. That's why my answer was wrong. Now is the answer correct? -6 and -8. So the answer is +3 now, right? Do we understand this? Now is it correct or still wrong?
-3, sir.
Oh, yes, it is -3. -3. Correct. So well done. Great. So what is the basic concept that we wanted to understand here? How do we find out whether the force displacement area is positive or negative? +4 because it is negative multiplied by negative, -2 because it is positive multiplied by negative, +1 because it is positive multiplied by positive, and -6 because it is negative multiplied by positive. Can we now move ahead? Do we all understand this? Yes or no? Anyone still has any doubt? So you can raise the doubt now. Else we will move ahead with the next thing, and the next thing would be important points about work done. Important points about work done. Okay. The first thing that you must understand is work done is integral of f dot dr, right? So we'll try to summarize everything that we have learned, and we probably would add some more points that would make them more enticing. Now, this formula, as you remember, is valid for all forces, whether those forces are constant, whether those forces are variable, every force in the universe, we will find out work done using this formula. The second important point is work done can be written as F dot delta R, but remember this formula is only valid. When is this formula valid? This formula is only valid for constant forces. It is valid only for constant forces. I think we all remember this, right? Now we can take the dot product of f with dr. I will get fx dx, fy dy, fz dz. I think you remember this. Now the third point, which was the first point that I was thinking to make. Now in this formula that we have written, delta w is integral of f dot dr. Now what we have to talk about here is this delta r. Now, what is this delta R actually? Now, this delta R is actually displacement of, and please remember this very carefully, displacement of point of contact of force. Now, these are very fine points about work done. You will not find it in any book, may not be even in your notes. These are specially meant to be discussed in the class. This delta R is the displacement of the point of contact of force, yeah, point of application of force. I can use a better word. This better word would be point of application of force. Now, what do I mean with this? I will try to illustrate it with some examples. Now, I'll make it as point number 4. Now, what is this displacement of point of application of force? Now, see, if a body is moving as one unit, I hope you are also noting it down with me. If a body is moving as one unit, the displacement of all points is same. Let us take an example. If you have a body like this, a body of mass m, now a force, we apply a force on this body, what happens is this body moves. Let us say that this body comes here. Now this entire thing is moving as one body. If something is moving as one body, we can take it as a particle. This pen moving like this. or moving like this. Now, if I take point number 1 here, point number 2 here, and if I look at the displacement of these 2 points, point number 1 has moved from here to here. If I call this displacement as delta R, you can understand that point 2 also has the same displacement. Do we understand this? Can I have some raise hand that we understand this? So when a body is moving as one unit, the displacement of all the points is same. Now, if we look at the point of application of force, this point, point number 3, is the point of application of force. How much this point of application of force has moved? And the answer is very simple. It has moved by the same amount. So if point 1 has moved by delta R, point 2 has also moved by delta R, point 3 has also moved by delta R. In this case, all points are having the same displacement. It is not a problem to find out the work done by this force. If this force is constant, it is simply equal to F dot delta R. If this force is not constant, we will integrate it F dot dr and integrate it from 0 to delta R, and you will get the answer. Do we all understand this? Can I have some raised hand that we understand this? Not everyone has understood this, boys, girls. Okay. So in this case, there is no problem. Displacement of all the points and force is same. Can there be a case where the displacements are different? Yes, there are a lot of cases where displacements are different. But those cases will come in your later journey after some time in rotation. All the points will have different motion. But right now, we are not discussing rotation, but we would be discussing some cases where displacement of different points are different. What is the case? If points have different displacements, then work done is found out with the displacement of which point? The point is point of application of force. If different points on the body have different displacements, then you have to find the displacement of the point of application of force. It might sound confusing कि सर ऐसा केस कहाँ पे बनेगा? How will you make a case where you will have different displacements for different points, and we are not talking about rotation at all? The case is very simple, and I'm going to make this case here, and this case we will be discussing in the next class also. This is a wall, as you can see, a wall on a floor, and we have this famous spring, and I have applied a force F on this spring. Once I apply a force on this spring, and I'm looking specifically at this point, and I move this point from here to here. So basically I've extended it. And this dash 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 tells me the extension. I've extended this point Point number 1, I have extended it to this point. Point number 2. Or I'll just call it point number 1 because this is the same point. Now this has been displaced by delta x. Now this delta x, you can call it as the extension in the spring. This delta x is the extension in the spring. So I had a spring and I applied a force F on it. The spring extends. The extension in the spring is delta x. Right? Now look at the different points on the spring. Do all these points have same displacement? And the answer is an astounding no. No, sir. All the points in the springs, they do not have the same displacement, because if I look at this point which is tied to the wall, when I'm extending the spring, is this point moving? This point remains at rest. This point doesn't move at all. So if this point doesn't move at all, and someone asks you, what is the work done by this force? You will be bamboozled. Okay, how to find it? One point which is tied to the wall is not moving. All the other points are moving differently. Which displacement would you use in this case? And then you must remember that we must look at the point of application of force. How much the point of application of force has moved. And in this case, the point of application of force has moved by a displacement of delta x, and hence delta x would be the displacement that we will have to use to find the work done by this force in this particular case. Do we understand this? Can I have some reason that we understand this? So right now in our discussion in this class for this topic, only this particular case, we will have different displacements for different points. And in this case, we have to find the displacement of the point of application of force. So remember, work done is F dot delta R, where delta R or dr is the displacement of the point of application of force. How much the point of application of force has moved, that displacement is used to calculate the work done by that force. I hope you have noted this thing down together with the diagram. Yes or no? I hope the answer is yes. That takes me to the next point. I think the point number is 6. What is the next point? Work done by a force is not, and remember this very important word, is not instantaneous. Work done by a force is not instantaneous. Work done by a force is not instantaneous. Why it is not instantaneous? It is always defined over an interval. To find the work done, you must always have an interval. Now, this interval can be an interval in terms of time, or it can be an interval in terms of distance, or it can be an interval in terms of displacement. For example, if someone tells you, what is the work done at 5 seconds? What is the instantaneous work done right now? Those things have no meaning at all. We have instantaneous velocity. We have instantaneous speed at any particular instant, velocity at any particular instant, acceleration at any particular instant. They are defined instantaneously. Power is defined instantaneously. But work done cannot be defined at any instant. Work done is not instantaneous. It's always defined over an interval of time. You must have two points. Between these 2 points, you can find out the work done. Between 1 second to 5 seconds, between 0 to 5, you can find out the work done over a time interval or over an interval of displacement or distance. You cannot find out instantaneous work done. And that is the reason that I have used this delta symbol with work done. This delta symbol tells me that it is always change. And why do I use this delta? Because that reminds me that it cannot be instantaneous. It is always between 2 points or a time interval. Do we understand why I always use the term delta? Because force is not instantaneous. It is always between 2 points or two interval or between an interval of time. Similarly, delta R is displacement. Now, displacement cannot be instantaneous because there is a delta written over here. It is always change. And therefore, when someone draws a graph between force and displacement, that graph is wrong, because then you are plotting displacement as a function of time. Displacement is never a function of time because it is not instantaneous. It is position of the particle, which is a function of time, and change in that position is your displacement. Do you understand what I'm saying? Can I have some raise hand that you understand what I have just now tried to make sense? Work done, displacement, they are not instantaneous quantities. They're always over one time interval. And hence, I have used the letter delta with them. Next point, work done by a force in a given interval. Work done by a force in a given interval does not, and you will be astonished, does not depend on the motion of the body. Oops, what do you mean by this? Now, you can have these questions as multiple choice or single option correct in JEE Advanced or JEE Mains. Work done by a force in a given time interval does not depend on the motion of the body. The body may be moving with uniform velocity. The body may be moving with uniform acceleration. The body may be moving with non-uniform velocity. The body may be moving with non-uniform acceleration. Doesn't depend on that. It has got nothing to do with what type of motion this body is having. I am moving a cart. Sometimes I move it, then I stop, then I again move, then I stop, then I again move, then I stop. Work done by the force that I'm applying does not depend on whether I'm moving it or stopping it, whether I'm moving with a constant velocity, whether I'm moving with a constant acceleration. Work done by a force is independent of the motion of the body. Do we understand this? Can I have some raise hand that we understand this? I'm not getting raised hand. Everyone is sleeping or not able to understand. Can I have some raise hand that we understand this? Okay. Work done in a given interval of time does not depend on the motion. If more than one force acts on a body, work done by any force is independent of work done by other forces. So, for example, I have 5 forces acting on a body: friction, normal reaction, if I call them as different forces, then some other force, then spring force, then gravitational force. I have 5, 6, 8 infinite forces acting on a body. And if I ask you, on what factor does the work done by gravity depend on? Work done by gravity only depends on the gravitational force, and it depends on the displacement of the particle, how much the particle has displaced. Work done is F dot dr. So it depends on displacement, it depends on the force, and it depends on the angle between force and displacement. It does not depend on whether other force is acting or not. So gravity will not find out, okay, I'm gravity, I'm acting on a body, I'll have to find out what other forces are acting, so that I can find out my work done. No, no, no. My work done, if I am gravity, does not depend on friction, does not depend on normal reaction, does not depend on spring force, does not depend on anything else. It only depends on work. It only depends on my force. How much is my force? It depends on the displacement, and it depends on the angle between force and displacement. Do we understand this? Can I have some reason that we understand this? Okay. If more than one force acts on a body, they are independent of each other. Now, if they are independent of each other, then I can write work done by all forces together will be equal to summation of work done by all the forces. I is equal to 1 to I is equal to n. Basically, if I have more than one force acting on a body, and I have to find the total work done. How do I find the total work done? I find the work done by first force, I find the work done by second force, third force, fourth force, fifth force, sixth force, and so on. And then I simply add all their works. That will be the work done by total forces cumulatively. To find out the total work done by all forces, find the work done by first force, find the work done by second force, third force, fourth force, and so on. Add them. Some might be positive, some might be negative. You will get the total work done by all forces. We also did an example on the same concept. And if you can recollect, this example that we did in the beginning of the class. Now, instead of thinking of this force as one, it was actually a part of one force. One was the x component, one was the y component, one was the z component. Instead of thinking of this force as one force, we can think of these forces as three different forces. One force acts along x, one force acts along y, one force acts along z. I had to find out the total work done by all these three forces. How did I do it? I found out the work done by the first force, that was plus 19. I found out the work done by the second force, that was plus 15 by 2. I found out the work done by the third force, that was plus 12. I added all these three works and I had the answer. How could I do it? Because work done by one force does not depend on the work done by other forces. And if I have to find out the total work, I can simply add all the work done by individual forces. So basically, point number 8 and point number 9 are saying the same thing. Point number 9 is derived from point number 8. Since work done by forces does not depend on each other, we can find out individual work done and add them together. If they were depending on each other, then we could not have done the same thing. Do we understand this? Can I have some raised hand that we understand this? Great. That takes us to the 10th point. Work done by a force depends on reference frame. It depends on your reference frame. Now, why does it depends on the reference frame? Why it depends on reference frame? The answer is pretty simple. If I look at the formula of work done, the formula of work done is F dot dr, where dr is the displacement. Now this displacement, this dr displacement, it depends on the reference frame. In different reference frame, there could be different displacements, and hence the work done by the force will depend on reference frame. Remember, force is independent of reference frame. Force does not depend on reference frame. Force is always independent of reference frame. If there is a force acting on a body, if this is a pen, this is a body, force of gravity is acting on it, in whatever reference frame you go, gravity will act on it and the value will be same. Force does not depend on reference frame, but displacement depends on reference frame, and hence work done also depends on reference frame. Do I have an understanding? Can I have some raise hand that we understand this? So these are all the simple points. Whatever you have to know, because these points can come as single option or multiple option in your exams. The last point, again, it is coming from all the previous points. Work done is independent of time. Unless and until the force is time dependent. If the force is time dependent, then it's a different issue. Otherwise, work done is independent of time. A simple example, I am pushing a block. Sometimes I push it, then I stop, rest. Then again I push it, I stop and rest. I take 10 minutes to go from A to B. In second case, I never rest. I push the block continuously and in 5 minutes I reach there. In one case, I have reached in 5 minutes. In the other case, I have reached in 10 minutes. My force does not depend on time. In this case, the work done by the force is time dependent. You rest, you accelerate, you move with uniform velocity, you move with variable velocity, doesn't matter. Force, work done by the force does not depend on your motion, uniform velocity, non-uniform velocity, uniform acceleration, non-uniform acceleration. It does not depend on time because it does not depend on all these things. It only depends on how much your displacement is. What is your force? Independent of reference frames. Force is independent of reference frame. Displacement is dependent on reference frame. Therefore, it depends on the reference frame and the angle between force and displacement. These are the three things on which work done depends on. In the next class, we'll also see work done by friction, where displacement will give us a problem. We will not say that work done by friction is dependent on displacement because it is somehow different. So that will be the topic of the next class. We'll be trying to find out work done by different forces, and we will get to know more about work done. I hope you have loved this class. I hope you have understood what we have said. We have discussed some important points about force. I will give you this sheet. I don't know whether you are allowed to use a mobile phone in your hostels, but I will put it in your group. So it will be there with you. Well, these are important points that I have given. So I'll give it. I hope that you can get it from the office with a printout. So probably you can take a printout of it and keep it with you. So I'll put it in the group. My class ends here. If you have any doubt, you can come up to me. Else, it's a bye-bye from my end. Take care and have a nice day.